This is the study guide for week 7 for Algebra B, quarter 3. So there's no test this week. We're just going over some concepts that we've worked on in the past. So let's take a look at the first one. It asks us to solve by factoring. And so when we factor, we always want to bring all the terms over to one side. I want to set it equal to 0. And so when I do that, I now have a problem in which I can draw the two parentheses and think of FOIL. And so I always look at the first and last terms and see if one of those numbers is prime. They're both prime, so actually it makes the problem easier. There's not a whole lot of choices here. I do know 3x and x make 3x squared. Now I need numbers that multiply to make -2, but as I do it, I'm trying to check to see if the outside and inside terms, they subtract to make -5x, and they do if I do it this way. Now if I want to make a -5x, I'm going to make the 6 negative, so put the minus sign with the 2. Because the 2 times the 3 makes the 6, so -2 and 3 make -6. Plus sign right here, and that will end up making this -5x. So I know I have the factoring done right. Now I have to set the two factors equal to 0. So I'm going to end up subtracting the 1 from both sides. I'm left with 3x equals -1. Divide by 3. Make sure you do that division of 3 there. So -1/3 is one of the answers. The other one I have x minus 2 equals 0. So all I have to do is add the 2 to both sides, and I get the answer. So x equals 2. So -1/3 and 2 are the two x-intercepts. So let's take a look at the next one. It says solve by using the quadratic formula. So quadratic formula in factoring, both those methods, you need to set them equal to 0. So now I got 2x squared minus 4x minus 1 all equals 0. And then I have to pull out my a, b, and c terms. So here's a, here's b, and here's c. So I'm going to plug them into that quadratic formula. So it goes the opposite of b. So 4 plus or minus the square root of -4 being squared minus 4 times a, which is 2, c, which is -1. This is all over 2 times by 2, 2a. And so we work a little further. So underneath the radical sign, we have 4 plus or minus the square root. And then here we have 16, always a positive, because two negatives make a positive. But watch the signs here. Negative and a negative are going to make a positive. So we're going to have to add, and this makes 8 when I multiply out those numbers. And this is all over 4. So we're going to end up leaving the problem just like this, underneath the radical sign, because it's not a perfect square, and we won't simplify it any further. And so we'll just leave it in the exact form. Well, taking a look at the next one, this is a tough problem because we have to complete the square, and it's got an a term. So first thing you're going to want to do is move that 3 back to the other side. So with completing the square, you've got to set it equal to the constant. So once I've done that, now I'm going to divide by 3. Every term you have to divide by 3. And so when I do that, I'm now left with this x squared minus 2/3 x equals 1. So what we want to do from here is figure out the two numbers that add to make -2/3. So all you're doing is taking half of 2/3. So when you do that, though, watch for the cross canceling. You end up with a -1/3. So that is the number that goes inside the sets of parentheses. So x minus 1/3 quantity squared. But I have to take that number and square it because I need to find out what it is that makes that factored form. So you've got the last terms need to multiply together, and you end up with 1/9. And so 1/9 is the number that you're going to end up adding to both sides. So the important thing is to add it to this 1. Well, 1 plus 1/9. So if I write down 9/9 for 1 plus 1/9 gives me 10/9. So 10/9 is the number that this binomial that's being squared equals. Well, the way we solve from here is we take the square root, and that will cancel out the squared symbol, and you'll always be able to take the square root of the denominator, not necessarily the numerator. In this case we won't. I'll leave it in the exact form. X minus 1/3 equals plus or minus the square root of 10 over 3. So from this point we're just going to take this 1/3 and move it back to the other side. So I'm going to end up adding 1/3 to both sides. And I end up with my answer. X equals, now I'll just write this as one fraction here, 1 plus or minus the square root of 10 all over 3. There it is. Well, the next one just says find the x-intercepts. That's basically what we did on these last three problems. So it doesn't specify the method, so we can use any method. So I'm going to go ahead and move this 12x back to the other side, and I end up adding it to both sides. And I'm going to choose factoring. So when I do this, I've got negative 9x squared, and then I've got a positive 12x, and a negative 4. Well, in order to factor, I like to have this equaling I like the a term to be positive. So I'm going to switch all these signs. I'm going to divide the entire equation by negative 1. So now I've got this 9x squared minus 12x, and then a plus 4, all equals 0. Well, when I look at it, I see 9 and 4. They're both perfect squares. So what my thinking is I think this is a perfect square trinomial. I think it's the same factors inside. So I'm going to try 3x and 3x. That multiplies to make 9x squared. 2 and 2 multiply to make 4. Now, in order to add to make a negative 12x, I'm going to try a negative and a negative and check the outside and inside terms to see if they do make the negative 12x. So this makes negative 6x, negative 6x. Yes, they do. They add to make negative 12x. So it does end up working. So we're only going to have one answer, so you don't need to find both because both are the same. So we're just going to take that 3x minus 2 and set it equal to 0. Add the 2 to all sides. Now we have 3x equals 2. Divide by 3. And there we've got our answer. X equals 2/3. 2/3. So let me fix that real quick. So 2/3. And that is our only x-intercept. So the vertex is right on the x-axis. So here it says determine the number of solutions. The number of solutions, we're going to use that discriminant. Remember, it's just b squared minus, it's just the b squared. Yes, so I've fixed this real quick again. B squared minus 4ac. It's just this portion. So remember, if this is positive, then we end up with 2 solutions. There's 2 solutions. If this were 0, there would only be 1 solution. And if this was negative, then we would have no solutions. 0 solutions. So let's go ahead and move this back to the other side. So it's part of the quadratic formula. So just like factoring, we need to set it equal to 0. So now we've got x squared plus 7 all equals 0. So we're going to use the a, b, and c values, but we don't have a b value. Notice that it's x squared plus 0x plus 7 is another way I can rewrite this. And then I'll take my a, b, and c values. So b is 0, so 0 squared minus a is minus 4 times a is 1, and 7 is the c value. When I do this work, I get 0 minus 28, which makes negative 28. So that means I have no solutions, 0 x-intercepts. So the answer, number of solutions, there's none. Well, the last problem here talks about Maria launched a rocket whose height in feet is given by the equation, it's listed there, where t is time in seconds. She claimed that the rocket could reach 100 feet. Is this possible? Why or why not? Well, all we're going to do then is take that 100 feet right there, and we are going to substitute it in for h. Because that's the height. H represents the height. So now we've got 100 equals negative t squared, negative 16t squared, plus 80t. And then from there, we're going to go ahead and move this, set this equal to 0, because we're going to use the discriminant, just like we did on that last problem. And so we'll take away that 100 from both sides. So now we've got negative 16t squared plus 80t, and then minus 100. And this all equals 0. So now we've got our a, b, and c values. We're going to substitute into our discriminant. So we've got 80 squared minus 4 times negative 16 times my negative 100. So we have to do some work here. 80 squared makes 64. 8 times 8 makes 64, but we have to have 2 zeros. It's going to be a negative, because count the negatives. We got 1, 2, 3 negatives. Odd number of negatives makes a negative. If I multiply 4 and 16, I get 64. Multiplied by 100, we get another 6400. So this equals 0. So that means that, yes, let's read what she says. She claimed that the rocket could reach 100 feet. Yes, it could reach 100 feet, but no more. And so we would say, yes, it's possible because the discriminant is 0. And that means it just touches 100 feet and then it falls back to Earth. Well, the last 3 problems are on part 2, so check that out.